Hello friends, I welcome you all to my channel. I hope you are all doing good and your studies are also going on fine. This is part 1 video on the chapter of factorization, where I will discuss about what is the basic concept of factorization of a polynomial, and how do we factor a monomial from a polynomial, and how do we factor a binomial from a polynomial. And also I will discuss about how to factorize a polynomial using grouping of terms. And finally, we'll solve some selected problems from the exercise 7A from the textbook of author RS Aggarwal. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel. And also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my quick notes prepared on the left hand side, and on the right hand side I will do the discussion and solving of the problems from the exercise 7A. I hope the notes, the fonts are big enough so that you can view it properly. Also, the PDF of the quick notes will be given in the description below. From there you can also check it out. Okay, so let's start discussing about the factorization of a polynomial. Now, what is meant by factorization of a polynomial? You know that a polynomial is an algebraic expression, that is, it could be a monomial, binomial, trinomial, quadrinomial, that is, it has one or more than 1, 2, 3, 4, 5, 6 terms, where the degree of the terms are, the degree of a polynomial is always a non-negative integer, that is, the powers of the variables in all the variables in the terms of of an algebraic expressions are always 0 or positive integers. So so when we say that factorize a polynomial, we mean to express the polynomial. Let's say P is a polynomial. So as I am speaking, you can follow the notes on the left hand side. So let's say P, so on the notes, let's say P is a polynomial, and when we express the polynomial P as a product of as a product of two or more algebraic expressions, then we say that P has been factorized. So let's say P is, I am taking an example, let's say P is the polynomial x square minus a square, where a is some constant and the variable is x. And we can see that x square minus a square is a polynomial because the power of the variable x is 2, it is an integer. Now we also know that when we say that how do we factorize this polynomial P? A polynomial is a single algebraic expressions. The moment we express a polynomial as a product of two or more algebraic expressions, then we say we have factorized P. And also notice that all the factors of the polynomial will be of lesser degree than the polynomial P. So in this example, P is a polynomial x square minus a square. We know that from the previous chapter of algebraic identities, a square minus b square is a minus b into a plus b. So we can say that x square minus a square will be x minus a multiplied by x plus a. So we have expressed the polynomial is x square minus a square as a product of two algebraic expressions, x minus a and x plus a. And also notice that the degree of the polynomial, I am denoting the degree by the letter d and a subscript p. So dp by d subscript p, I mean that it is the degree of the polynomial p. So this is my convention. It is not any standard convention used in the book. This is what I am. This is my convention just to facilitate the discussion. Okay, so we can see that the degree of the polynomial x square minus a square is 2. Now also see that the degree of these two polynomials or algebraic expression x minus a is 1 and x plus a is also 1. So the degree of the factors, when you factorize a polynomial as a factor of two or more polynomials, the degree of those polynomials, the degree of those factors will always be less than the degree of the original polynomial. So this is the basic concept, that you express a given polynomial as a product of two or more polynomials, where each of those individual polynomials will have a lesser degree than the original polynomial. Okay. Now, in the notes, you will have some examples. I will not go through the examples. You can check the notes. Okay. Let's now, what is how we actually do factorize a polynomial. So there are some basic tools or methods or concepts that we apply to factorize a given polynomial. Okay. So the first one is, the very basic method is, how do we factorize a monomial from a polynomial? Now, what is meant by factoring a monomial from a polynomial? Now, monomial is a term. A term or a monomial is the same thing. Let's say, now I will take some concrete examples. So let's say I have a polynomial p, let's say, is equal to x square plus twice ab. We have, let's say, not x square, let's say x cube minus x. We have this polynomial x cube minus x. Now when we say how do we factor a monomial from the polynomial, it means that first we have to identify the common factor from all the terms. We have to see all the terms and they must be having a common factor. For example, in this polynomial x cube minus x, we can see that x is a common factor to all the terms. So we have to first identify the common factor present in all the terms. For this polynomial p, we can say that common factor, in the notes I am denoting that common factor, which is a monomial, as m. So in this example, x cube minus x, m will be x, because x is the common factor to all the terms. So what are the terms? Terms are x cube and minus x. Okay. Now what we do is we divide the polynomial with this common factor, and I'm let that be q. Let q is the polynomial obtained by dividing the original polynomial by the common factor. So basically q is x cube minus x divided by x. Now if you do this, this is equal to x cube minus x divided by x. This is equal to x square minus 1. Now now we will have the final factorization of the polynomial p as m multiplied by q. M multiplied by q, that is the product of m and q, is the factorization of the polynomial p. So for this example, we will have m is x and q is x square minus 1. So this product x multiplied by x square minus 1 is the factorization of the polynomial p. So this was the very basic examples. I'm not taking very complex examples. I'm just trying to explain the concept. So this is what this is about, factoring a monomial from a polynomial, where you identify a common factor from all the terms in the polynomial, and then you express the polynomial as the product of that common factor multiplied by the polynomial obtained by dividing the original polynomial by the common factor, that is q. So hence we see that p has been expressed as the product of two algebraic expressions m and q. So this is what we call as factorization of the polynomial p by factoring a common monomial. Let's take some few more examples so that you will get the proper idea. So let's say I have a cube b square, a polynomial. Let's say polynomial p is a cube b square minus twice ab plus, let's say, ab square. Now, so this is a polynomial trinomial having three terms. The terms are a cube b square and minus 2ab and ab square. First, we have to identify the common factor in all the terms. Common factor in all the terms. So for this polynomial, the common factor m will be equal to ab. Now you must be very thorough and very clear about finding the identifying the common factor in all common factor in a give in all the terms of a polynomial. Now the okay, so this because the common factor is ab. Now what will be q? Now what is q? Q is you divide the original polynomial by the common factor. So this is original polynomial is a cube b square minus twice ab plus ab square divided by the common factor, that is ab. Now if you do this, now division, addition, subtraction, multiplication of algebraic expressions we have already covered in the from the previous chapter from the textbook of author RS Aggarwal, which was operations on algebraic expressions. If you have not watched those videos, I strongly suggest that you watch those videos also to get a good understanding of the chapter concepts. Okay, so when I divide when I do the division of the polynomial p by ab, I get a square. I get a square b, and I get minus 2, and I get plus b. So q is b. Q is a square b minus 2 plus b, and hence the factorization of the polynomial will be m multiplied by q, that is the common factor was ab, and then q is a square b minus 2 plus b. So this is the factorization of the polynomial p. So when you factor a monomial from a polynomial, you always get a product of two algebraic expressions. Okay, I hope you got the basic idea of factoring a monomial from a polynomial. Let's move forward. Let's see what do we have next. Now, next is how do you actually identify the common factors of terms. I hope you are already aware and you know the concept how to identify the common factor of a few terms. The idea is that first you have to identify. So let's say I have some terms. Let's say minus x square y z. Let's say I have another term half x cube z square, and let's say I have first one is x square y square, and second term is half x cube z square y square, and let's say another one is let's say 12. Let's say the coefficient of the second term is 6, and the third term is 12 x to the power 4, let's say y to the power 6, and z cube. Now, how do you the concept is very basic, but still I'm just trying to discuss the logic. How do you find the common factor from given terms, from a few terms, or from a terms of a polynomial? So let's consider these three terms. What will be the common factor? First, to identify all the variables that are present in all the terms. I can clearly see those variables are x. The variable x is present in all the terms, in all these three terms. The variable y is also present in all the three terms, and also the variable z is present in all the three terms. Now, you have to identify what will be the powers of these three variables. Now, the power of x will be the minimum power that you can see, the minimum power of x that you can see in all these three terms. So for the first term, the power of x is 2. For the second term, the power of x is 3. For the third term, the power of x is 4. So among 2, 3, and 4, the minimum value is 2. So the power of x in the common factor will be 2. Similarly, you will do for the variables y and z. The minimum power of y, the variable y, in these three terms is square, and the minimum power of the variable z is z, because the first term has the power of z as 1. So this becomes the common factor of x square y square z, becomes the common factor of these three terms. So first you identify all the variables that are present in all the terms, and then you, for the power of those variables, you take the minimum power available in the terms, and then you take the product of those variables and their powers and their minimum powers. That is the basic concept, how you identify a common factor in a list of terms. Okay. Next is, how do we factor a binomial from a polynomial? You are given a polynomial. How will you factor a binomial? The concept is very similar to factoring a monomial from a polynomial. First, you have to identify the binomial which is common factor of the polynomial p. So, and then so if that common factor, if that common binomial which is a common factor of the polynomial p is b, then you find q, which is p divided by b, and then the factorization of p will be b multiplied by q. Okay, so let's say you have a polynomial p of the form, let's say you have so let's say 4y multiplied by 2x minus 3, and you have minus 6 multiplied by 2x minus 3. This is a given polynomial, let's say. So you can clearly see that all the terms are having 2x minus 3 as a common factor, and 2x minus 3 is a binomial. It has two terms, 2x and minus 3. So I can clearly, from this polynomial, I can clearly say that the common binomial, which is a common factor of all the terms of the polynomial p, is equal to 2x minus 3. And now I will find q, which is p, the polynomial p, original polynomial p divided by the binomial, that is a common factor binomial, p divided by p. This becomes 4y multiplied by 2x minus 3 minus 6 2x minus 3 divided by b is 2x minus 3. So now this becomes 4y 2x minus 3. This is now where and now your concept of the previous chapter, that is addition, subtraction, multiplication and division of polynomials, will come into play. You must be having a very clear understanding of the concepts of the previous chapter, that is algebraic expressions and identities, which is in the name of operations on algebraic expressions in the textbook of author RS Aggarwal. Okay, so we have this, and 2x minus 3 divided by 2x minus 3. Now, as you can see, this will be 4y minus 6. So the common factor, which is a binomial, so q, which is the original polynomial divided by the common factor binomial, is 4y minus 6. Hence, we can now express p as a factor of two algebraic expressions, that is b into q, which is 2x minus 3 multiplied by 4y minus 6. Now, from the given polynomial, this, you should be, the more you solve problems, you will get used to these methods of factorization, and you should be able to factorize this polynomial p immediately as the product of two the binomials, that is 2x minus 3 and 4y minus 6. So this was how do you factor out a binomial from all the terms of a polynomial. Okay, The final concept is, I will quickly check whether everything is okay. The final concept is, how do you factorize a polynomial by grouping? By grouping. Now, what does it mean? What does grouping means? The grouping means that you are given a polynomial. It is sometimes you have to rearrange the terms. You have to group. You have to form groups by taking suitable terms, so that each group will have a common factor, and that common factor you can factor out from the polynomial. So let's say, so the idea is that you have a polynomial. Let's say you have a polynomial. Okay, so you have a polynomial. Let's say you have okay, I am taking the example in the notes only. You are having the polynomial x square plus let's say xb plus xa plus b square. You are having this polynomial now, and you are asked to factorize the polynomial p. Now you can see that you cannot factor out a monomial from the polynomial, because all the terms are not having any common factor. You will not find a common factor. You will not find algebraic expressions or a factor which is common to all the terms. That is not possible. Okay. You can also see that all these terms do not have a common factor which is a binomial. No terms in this polynomial is having a common factor which is a binomial. That is also not possible. But now comes the role of grouping terms. Now I will group. I will group I will form groups. Now what is a group? A group is a collection of few terms, and those terms will have a common factor. Now I can see that this grouping of terms, so that each group has a common factor, you have to observe and do the grouping. There is as such no mathematical way of doing that. You have to observe all the terms, what are the variables of each terms, and figure it out. How will you do the grouping of the terms? Now I can see that if I form two groups, if I form a group of the terms x square and xa, if I consider this as a group, I can see that, okay, let's group the terms. I form this group, and the remaining two terms I will form another group. So we have two groups. The first group is consists of the terms x square and xa, and the second group is so this is group 1, and let's say this is group 2. So I'm just explaining what is meant by grouping. So I have taken the terms x square and xa and have formed a group, that is x square plus xa, and I have taken the terms xb and b square, formed another second group, that is xb plus b square. Now why I did this? Because I know now if I see from the group 1, if I take a common factor as x, I can see that the group 1 has a common factor, monomial factor, which is x, because all its terms is having the common factor monomial x. So if I factor out x from the first group, I get x into x plus a, and from the second group I can see all the terms are having a common factor b. So if I factor out b from the second group, I get b into x plus b. Oh no, sorry, x plus b. Let me one second. So this is not b square, sorry, this will be ab. This is not b square, but this is ab, my mistake. Okay, so if so from the second group I see there is a common, all the terms, that is xb and ab is having a common factor b. So if I factor out b, I get x plus a. Now I see that the two groups G1 and G2 are having a common factor of x plus a. As you can see, this was the group 1 and this was the group 2, and I see both the groups are now having a common factor x plus a. So I will just now factor out the binomial x plus a from the two expressions, and I get x plus a multiplied by x plus b. So this is the final factorization of the given polynomial x square plus xb plus xa plus ab. So this is the concept of grouping. That is, from a given polynomial, you won't find that all the terms are having a common factor as a monomial. You will also find that all the terms are not having a common factor as a binomial. But if you if you form groups of terms, if you take suitable terms to form a group, then you will see that each of those groups will have a common factor, and that common factor it will be usually a binomial. And then you factor out the binomial using the concept of factoring a binomial from a polynomial, and you will get you can express the given polynomial as a product of two or more two algebraic expressions. So that was all regarding the concept of factorization of a polynomial using the concept of factoring a monomial from a polynomial, factoring a binomial from a polynomial, and factorization of a polynomial using by grouping. Okay, now let's try to apply these concepts to solve some selected problems of from the exercise 7a. By solving these problems, it will be more clear how the concepts will work. Okay, I hope you can see the problems of exercise 7a on the left hand side. Let's start solving the problems of exercise 7a. So this is from the textbook of author RS Aggarwal. Okay. Problem number 1, we have to factorize. No, how many questions are there? There are 28 questions. Okay. So first part of problem number 1, it is asking to factorize 12x plus 5. So it is this is the given polynomial, and I will try to solve the problem as per the quick notes, so that you can correlate the quick notes with the solving of the problem. So p, the polynomial p, is given as 12x plus 15. Now first you will try to see if you can figure out a common factor from all the terms of the polynomial. That common factor will be a monomial. I can see that all the terms in this polynomial, there are two terms. First is 12x and the second is 15. I see a common factor of 3 from these two terms, because 12x is 3 into 4x, and 15 is 3 into 5x. And I can see that 3 can be taken as a common factor. 3 is also a monomial. So I can say that I can now take out, this was 3 multiplied by not 5x but 3 into 5. I can see that 3 can be taken, 3 is a common factor in all the terms. So I can factor out 3, and I get 3 multiplied by 4x plus 5. So this is the factorization of the polynomial 12x plus 15. Let's now, if this is p, you can say that the common factor monomial in all the terms is 3, and also q, that is q will be the polynomial p divided by m, that is p is 12x plus 5 divided by m is 3. Hence we get 4x plus 5. So the factorization of P will be M into Q, which is equal to 3 into 4x plus 5. Okay, let's do problem number 2, part 1. It is 16a square minus 24ab. You have to be very very clean and very clear about identifying the common factor of all the terms of a polynomial. So this is a binomial 16a square minus 24ab. What will be the common factor in all the terms? Clearly we can see a common factor in all the terms. The common factor M will be, first you will notice the common factor from the coefficient, that is the coefficient of all the terms. The coefficient are 16 and 24. So you have to consider, the common factor. The common factor will be if all the terms of the polynomial have a numerical coefficient which is not equal to 1, then you have to consider the HCF, that is the highest common factor of all the numerical coefficients of all the terms. That will become the coefficient of the final, that will become the coefficient of the common factor. So I can see the coefficient means the numerical coefficient of a term. The first term 16a square, the coefficient is 16, and for the second term the coefficient is 24. So what is the HCF of 16 and 24? HCF of 16 and 24, I guess is 8. So is 8. Okay. Now what will be the variables in the common factor M? As I already discussed, first identify all the variables which are present in all the terms. I can see that only the variable A is present in both the terms, that is 16a square and minus 24ab. And the first term has a square, the power is 2, and the second term has a power as 1. So the minimum power is 1. So definitely the common factor will be then 8 into a. So we have found the common factor of all the terms of the given polynomial. Now we have to find Q, which is equal to the polynomial. Polynomial P is this. Polynomial P divided by the common factor M, which is equal to 16a square minus 24ab divided by 8a. Now I am doing this step by step just to illustrate, just to discuss the concepts. But while you are solving your problems in your exam or any competitive examinations, definitely you will not write all this Q and M. You have to do this. You can do that as a rough work, but in the actual solving, you should not be using these letters P and M. Those are just for discussion purpose. So this will be equal to twice of A and minus 3B. So this implies, now I can say P, the factorization of the polynomial P will be equal to M into Q, which is M is 8A and Q is 2A minus 3B. So 8A multiplied by 2A minus 3B is the factorization of the given polynomial. Okay, let's do part 3. Problem number 2, let's do part 3. Part 3 is P is given to be 12 x square y cube minus 21 x cube and y square. Now I have to first identify the common factor, as I can clearly see that all the terms will have common factor because all the terms are having the variables x and y, and also both the coefficients of the terms will have some common coefficient. As I can see that the coefficient of first term is 12, the coefficient of the second term is 21, and I have to find the HCF, that is the highest common factor between 12 and 21, which I guess is 3. Okay, so what will be m, that is the common factor. So let's we can see that both the variables x and y are present in all the terms. So what will be the power of x? First we write the coefficient, the common coefficient, which will be the HCF of 12 and 21, which is 3. Okay, now we write the variable x and its power. The minimum power we can see is x square 2, so it will be x square, and the minimum power of y we can see is 2, so it will be y square. Hence 3x square y square is the common factor in both the terms of the given polynomial. This implies q will be p divided by m, which is equal to 12 x square y cube minus 21 x cube y square divided by 3 x square y square. So this is equal to this will be equal to 4 y minus 7x, 4y minus 7x. This implies that the polynomial p can now be factorized as m into q, a product of m and q. M is 3x square y square and q is 4y minus 7x. So this is the factorization of p. Okay, let's do problem number 3. I skipped the problem number 3 because these are all similar to problem number 2. Let's start from problem number 4, where we have the polynomial, given polynomial is a trinomial. So problem number 4, let's do part 1. So the given polynomial is 9x cube minus 6x square plus 12x. Now this is also pretty straightforward because you can see that all the terms of this polynomial will have a common factor. So m, we can clearly find the m, that is a common factor, which will be a monomial. Now first we have to find the coefficient of this common factor m. What will be the coefficient? The coefficient will be the HCF, that is the highest common factor of all the coefficients of all the terms, that is 9, 6. Ignore the sign of the terms. Ignoring the sign of the terms, find the highest common factor HCF of all the coefficients of the terms, ignoring their sign. So we have HCF of 9, 6 and 12, and the HCF is obviously 3. So we will have 3, and then we will have product. We can see that there is only, this polynomial has only one variable, that is x, which is present in all the terms. Now what is the minimum power of x in all the terms? That is 1. 12x, the power of x is 1, which is the minimum. So we will have x in the x to the power 1 in the common factor m. So this becomes 3x. So 3x is the common factor of all the terms of this polynomial. So now we will find q, that is p, the original polynomial divided by the common factor, which is 9x cube minus 6x square plus 12x divided by 3x, which is equal to 3x square minus 2x plus 4. So this is q. So this implies the factorization of the polynomial p will be m multiplied by q, and this is 3x multiplied by 3x square minus 2x plus 4. So this is the final factorization of the given polynomial. Okay. Okay. Okay, let's do part 2. Let's do all the parts of the problem number 4. Let's do part 2. So while I'm solving the problems, if you think if you think the solution of this problem will be beneficial to you, will help you, then you can pause the video and take screenshot of the solution. Okay, so part 2, the polynomial p is given as 8x square minus 72xy plus 12x. Clearly, you can see that all these terms will have a common factor because x, the variable x, is present in all the terms. Okay, so we first find to figure out what the common factor will be. That is the common factor which is a monomial. First, we find the HCF of the numerical coefficients ignoring the sign of all the terms. That is HCF of 8, 72, and 12. What is the HCF of 8, 72, and 12? I guess it is 4. I hope it is 4. Okay, 4. So it will be 4 multiplied by, I can see the variable x is present in all the terms and the minimum power of x is 1. So it will be x and nothing else will be there in the common factor. So this becomes equal to 4x. The common factor is 4x. Now you find q, that is the original polynomial p divided by the common factor m. So this becomes 8x square minus 72xy plus 12x divided by 4x. This is equal to 2x minus 18y plus 3. Q is this. So now we can say that the factorization of the polynomial p will be equal to m multiplied by q. That is m is 4x and q is 2x minus 18y plus 3 Okay, let's do part number 3. Part 3 is the given polynomial is 18a cube b cube minus 27 a square b cube plus 36 a cube b square So we can clearly see that the variables a belongs to all the terms, a variable b also belongs to all the terms. So we will definitely have a common factor. So we can say m, we have to figure out what is m, that is a common factor in all the terms. So what will be the coefficient of the m? It will be the HCF of coefficients of all the terms ignoring their sign. So HCF of 18, 27 and 36 is will be 9. Okay, so we will have 9 multiplied by, we can see the variable a is present in all the terms. So what will be the power of a? The power of a will be the minimum power of a, you can see in the terms, that is the minimum power is 2, which belongs to the second term. So it will be a square. We also see that the variable b occurs in all the terms, and we have to find what is the minimum power of b occurring in any terms, and the minimum power is b of b is b square, which is occurring in the third term. So we will have b square. So the common factor is 9 a square b square. Hence, now we can find, you have to find q, that is the original polynomial, given polynomial divided by the common factor m, which is equal to 18a cubed b cubed minus 27 a square b cubed plus 36 a cubed b square divided by m. M is 9 a square b square. So this is equal to twice of a b and minus 3 b and plus 4 a. Now you must be very thorough in doing the division of a polynomial by a monomial or a polynomial by a binomial. That is your concepts from the previous chapter, that is addition, subtraction, multiplication, division of algebraic expressions must be very clear and thorough. Okay, so now the factorization of polynomial p will be equal to m multiplied by q. M was 9a square b square and q was twice ab minus 3b plus 4a. So this is the factorization of the given polynomial. Okay, let's do problem number 5. Problem number 5, part 1. The polynomial, given polynomial is 14 x cubed plus 21 x to the power 4 y minus 28 x square y square. Okay, so we can clearly see that all the terms are having the variable x. So definitely all the terms will have a common factor, that is a monomial, which is common to all the terms. So we have to find the monomial, the common factor m. What will be the coefficient of m? It will be the HCF of the coefficient of all the terms ignoring their sign, that is 14, 21 and 28, which is the HCF is 7. Okay, so we have 7 multiplied by the variable x is occurring in all the terms and the minimum power of variable x is 2. So we have x square and the variable y is not occurring in all the terms. So definitely y will not be there in m. So this becomes 7x square. So now we have to find q, which is p divided by m, which is equal to 14x cube plus 21 x to the power 4 y minus 28 x square y square divided by 7x square. This is equal to twice x plus 3x square y minus 4 y square. So the factorization of the polynomial p will be equal to m multiplied by q, which is equal to 7x square multiplied by twice x plus 3x square y minus 4 y square. So this is the factorization of the given polynomial. Okay, let's do part 2. Part 2, the given polynomial is given as minus 5 minus 10t, here t is the variable, and plus 20 t square. Now clearly you see that t, the variable t is not present in all the terms. The first term is not having the variable t. But so what can be, is there any common factor? Of course there is a common factor, because you can see the numerical coefficient, all the numerical coefficients or the coefficients of the terms are having, will have a common factor which is not equal to 1. If you have, if all the terms of a polynomial, they do not have a common factor of variables, but if they have, if their coefficients have a common, if the HCF of the coefficient is an integer which is not equal to 1, Then also you will have a common factor of the polynomial, which will be the HCF of the coefficient of all the terms, which will be the case for this problem. So we can see that this implies m will be equal to, we see the HCF, the highest common factor of all the coefficients of all the terms will be, ignoring the sign, is 5, 10 and 20. HCF of 5, 10 and 20. So this is equal to 5, and hence the common factor will be only 5. There will be no variables because all the terms are not having any common variable. So n is 5. So this implies q will be p divided by m, that is minus 5 minus 10t plus 20t square divided by 5. This is equal to minus 1 minus 2t plus 4t square. So now we will have the factorization of p is equal to m multiplied by q, which is equal to, m was 5 and q was minus 1 minus 2t plus 4t square. So this is the factorization of the given polynomial p, where it is a product of a monomial. 5 can be considered as a monomial because 5 is a constant term. Okay. Okay, let's do problem number, let's do problem number 6. Problem number 6, part 1 is x multiplied by x plus 3 plus 5 multiplied by x plus 3. So in this polynomial p, we can see that we can see a common factor of x plus 3. So x plus 3 is a binomial. So we see that the common factor, which is a binomial, is x plus 3. So now we will find q, which will be the given polynomial p divided by the common binomial p by b, which is equal to x into x plus 3 plus 5 into x plus 3 whole divided by x plus 3. So this is equal to x plus 5. This implies the factorization of p will be equal to b into q, which is equal to, b was x plus 3, b was x plus 3 and q is x plus 5. Okay. Part 2 and part 3 are very similar to part 1, so I am not doing that. Let's do problem number. Now, if you see all the parts of the problem 7, 8 and 9, they are also very similar. You can clearly see the common factor, which is a binomial, and you can factor out the binomial. Let's do problem number 7 just for the sake of illustration. We have the polynomial p is 6a multiplied by a minus twice b plus 5b a minus twice b. So if we consider the p as composed of two parts, that is this part and this part, you can see these two parts are having a common factor of a minus 2b. A minus 2b is present in both the parts. So so the binomial, which is a common factor, is a minus 2b. A minus 2b. Now we have to find q, that is p divided by b. P divided by p, that is 6a multiplied by a minus 2b plus 5b multiplied by a minus 2b divided by a minus 2b. This is equal to 6a plus 5b. So now the factorization of the polynomial p will be equal to b into q, which is equal to a minus 2b multiplied by 6a plus 5b. So problem 8 and 9 are very similar to problem 7, so I am not doing it. Let's do problem number 10. Let's do problem number 10. The given polynomial p is given as x plus 5 square minus 4 into x plus 5. Now this is equal to x plus 5 whole square, means x plus 5 multiplied by x plus 5. Now we can clearly see that x plus 5 is a common factor. We can visualize this polynomial p as having two parts, this part and this part, and all these two parts are having x plus 5 as the common factor. So we can clearly see that the common factor, which is a binomial, is x plus 5. So this implies q will be equal to p divided by b, which is equal to x plus 5 multiplied by x plus 5 minus 4 into x plus 5 divided by b. B is x plus 5. So this is equal to x plus 5 minus 4, and this is equal to x plus 1. Hence the factorization of the polynomial p will be equal to b into q. B was x plus 5 and q is x plus 1. This is the factorization. Okay. Let's do problem number 12. Let's do problem number 12. The given polynomial is twice a plus 6b minus 3 into a plus 3b square. Now you may not be you cannot immediately see that any common factor which is a monomial or a binomial, you cannot immediately factor out any monomial or a binomial from this polynomial, but you have to, if you can simplify a little bit, you see this part, if you take out 2 as the common factor, I can see this as a 2 into a plus 3b minus we have 3 into a plus 3b square, means a plus 3b multiplied by a plus 3b. Now if you consider these two parts, you will see there is a common factor of a plus 3b. So this will imply that b is equal to a plus 3p. And now you have to find q, which is equal to p by b, which is equal to 2 into a plus 3b minus 3 into a plus 3b multiplied by a plus 3b whole divided by b, and b is a plus 3b. So this is equal to 2 minus 3 into a plus 3b. 2 minus 3 into a plus b. This implies we can say that the factorization of polynomial, the given polynomial, will be b multiplied by q. This is equal to a plus 3b multiplied by 2 minus 3 into A plus 3B. So this is the factorization of the given polynomial. Okay. Let's do problem number 14. Problem number 14 is the polynomial P is given as x multiplied by a minus 3 plus y multiplied by 3 minus a. Now we can see that even though we immediately do not see any common factor exactly, but we know that a minus 3 is the negative of 3 minus a. So we can simplify or rewrite the given polynomial as 3 minus a can be written as negative of a minus 3. So now this becomes x into a minus 3 minus of y into a minus 3. Now we see that the common factor, which is a binomial of this polynomial, is the common factor as a binomial is a minus 3. So this will imply q will be equal to p by b, which is equal to x into a minus 3 minus y into a minus 3 divided by a minus 3, which is equal to x minus y. Hence, the factorization of the polynomial p becomes p into q, which is equal to a minus 3 multiplied by x minus y. Okay. Problem number 15 I will not do. I have already done a similar problem. Let's see whether we can do any other problem. Let's see. Let's do problem number 17. Problem number 17, the polynomial P is given as AR plus BR plus AT plus BT. Now clearly you can see that the terms, we do not find any common factor of all the terms. There is no common factor of all the terms of this polynomial P, and we also see we cannot immediately see any common factor which is a binomial of this polynomial. So we can try to use the method of grouping. Now, so we will now try to group the terms so that each group will have a common factor. Now, if you group AR plus AT, you can factor out A and you will have A into R plus T. So this thing you have to be observe all the terms and figure it out how to do the grouping. So if I group AR plus AT, this is the first group, and the second group is BR plus BT. So this is equal to, from the first group I can take out A as the common factor and I get A into R plus T, and from the second part this I can factor out B and I get B into R plus T. Now I see that these two terms are having a common factor R plus T, which is a binomial. Now I can say that the common factor which is a binomial is R plus T. This implies Q will be P by B, which is equal to A into R plus T plus B into R plus T, R plus T divided by what was B? B was R plus T. So this is equal to A plus B. Hence, the factorization of the polynomial P becomes B multiplied by Q, which is equal to B was R plus T and Q is A plus B. This is the factorization of the polynomial P. Okay, let's do problem number 18. the polynomial p is given as x square minus ax x square minus ax minus bx plus ab. So we can clearly see that there is no common factor of all the terms. Also, there is no common, we cannot see any common a binomial as a factor. So we will try to see if we can form groups so that each group will have a common factor. So if you group x square minus ax, you can factor out x and you will have x into x minus a. Okay, so I think it will work. Let's group x square minus ax and let's group plus ab minus bx. From this part we have formed two groups. This is group 1 and this is group 2. From group 1, if I take out x as a common factor, I get x into x minus a, and from the second group, if I take b as the common factor, I get b into a minus x. A minus x. Okay. Now if you have two parts, now a minus x and x minus a are negative of each other, so I can rewrite it as x into x minus a minus of b into x minus a. So now we see there is a common factor of x minus a in this polynomial. So this implies the common factor, which is a binomial, which is x minus a. And now we will find q, which is equal to p divided by b, which becomes x into x minus a minus b into x minus a divided by x minus a, which becomes x minus b. And hence the factorization of the polynomial p becomes b into q, which is equal to x minus a multiplied by x minus b. Okay. Let's do problem number 19. The polynomial p is given as ab square minus bc square minus ab plus c square. So clearly we can see there is no common factor of all the terms. That is, there is no common monomial factor from all the terms. Also, we cannot see any common factor which is a binomial. So we can try to figure it out. We can try to see if we can apply the method of grouping. If we can group some terms so that each group will have a common factor. Now, if we form a group like this, from the first group we can take out a b. We can take out b as a common factor, and I will get b into ab minus c. AB minus c, but from the second group ab plus c square, we will not get any common factor. Okay. So let's try to, this will not work. Let's form the group of ab square minus ab. This is the first group, and let's say we have c square minus bc square. Okay, so from the first group, so this is the group 1 and this is the group 2. The first group we can take ab as the common factor. We can see the first group, the terms ab square and minus ab, they have a common factor of ab. So let's take that out, and we have ab multiplied by b minus 1. And from the second group we can also see we can factor out c square. we can factor out c square. So we have c square multiplied by 1 minus b. So now we see that the polynomial, from this we can now b minus 1 and 1 minus b are negative of each other. So we can rewrite it as b minus 1 minus c square b minus 1. So now we clearly see that b minus 1 is a common factor which is a binomial for of this polynomial. So we can say that the common factor which is a binomial b is b minus 1. This implies q will be p by b. P is the original polynomial, which is ab into b minus 1 minus c square b minus 1 divided by b minus 1. This is equal to ab minus c square. So the factorization of the polynomial p becomes b into q, which is equal to b minus 1 multiplied by ab multiplied by ab minus c square. This is the final factorization. Okay. Now I will not do question number 20 and 21, which are similar. In the applying, you will have to apply the concept of grouping. And let's do 23. Let's do 23. These are the rest of the problems are all based on grouping. Let's try to solve few of them. 23. The polynomial p is y square minus xy multiplied by 1 minus x minus x cube. Clearly, we can see that all the terms do not have any common factor as a monomial or as a common factor as a binomial. Okay, so this is y square minus, if I apply the product of do the product of xy into 1 minus x, I get xy plus x square y minus x cube. Now we have to see if we can group terms so that each group will have a common factor. From, if I form a group of this as a group y square minus xy, I will have a common factor of y, and it will be y into y minus x. And from this group I can factor out x square and I will have y minus x. So we will group like this. Now this grouping will come with practice. You have to observe the terms and find how you can arrange the terms into groups so that you can have all the groups will have a common factor. This will come with a lot of practice. So this becomes the group 1 and this becomes the group 2. From the group 1 we can factor out y, and we have y into y minus x, and from the group 2 I can factor out x square and I have y minus x. Now you can see that the polynomial is having a common factor of y minus x, which is a binomial. So b is y minus x. So this implies q will be p by b, which is equal to y into y minus x plus x square y minus x divided by b. B is y minus x. So this becomes y plus x square, and hence the factorization of the polynomial p is b into q, which is equal to y minus x multiplied by y plus x square. Okay, let's see what other problems we can do. Let's do 24. Let's see. Let's do problem number 24. Polynomial p is given as ax plus by whole square plus bx minus ay whole square. Now clearly we can see that we cannot see any there is no common factor between these two, that is ax plus by whole square and bx minus ay whole square. There is no common factor, so definitely we have to expand the squares and simplify the polynomial. So if I apply the formula identity of a plus b whole square and a minus b whole square, I get a square x square plus b square y square plus twice xy ab, and we have, this was the expansion of the first square. If we expand the second square, that is a minus b whole square, we get b square x square plus a square y square minus twice ab xy. Okay, so this is equal to a square. If we open the brackets, we get a square x square plus b square y square plus twice xy ab plus b square x square plus a square y square minus twice ab xy. So twice ab xy gets cancels out, and we see it becomes a square x square plus b square y square plus b square x square plus a square y square. Now we can clearly see that there is no common factor in all the terms. Also there is, we cannot see any common factor as a binomial. So obviously we have to see if we can form some groups so that each group will have a common factor. Now if you group a square x square and b square x square, and the second group as b square y square plus a square y square. Now from the first group you can take x square, you can factor out x square, and you get x square into a square plus b square. From the second group you can factor out y square, and you get y square into a square plus b square. Now we can see that we see a binomial a square plus b square as a common factor. So we can say that the common factor which is a binomial is a square plus b square, because this part and this part both are having a common factor of a square plus b square. So now q will be equal to p by b, which is x square into a square plus b square plus y square into a square plus b square divided by b, which is a square plus b square. This is equal to x square plus y square. Hence this implies the factorization of p becomes b into q, which is equal to a square plus b square multiplied by x square plus y square. So this is the factorization. Okay, this was problem number 24. Let's do let's do all of them, 25, 26, 27, 28. These are all based on grouping. 25, the polynomial p is given as ab square plus a minus b, a minus 1 into b minus 1. So clearly we see there is no common factor as a monomial, that is all the terms are not having any common factor, or even we cannot see any common factor as a binomial. So we will have to further simplify the polynomial, that is we have to find the a minus b into b, that is ab minus b, and we have minus 1. So this is the polynomial. We have to use the method of grouping. We have to form groups. So we form the groups a b square plus ab, and we form the group of plus these two terms, the minus 1 minus 1. So this is equal to ab square plus ab, and the minus 1 minus b minus 1, we can take minus 1 as common, and this will be minus of b plus 1. From the first grouping, this was group 1 and this was group 2. From the first grouping, you can take out, we can see that all the terms, that is ab square plus and ab, are having ab as the common factor. So take out ab as common factor, and I get ab multiplied by b plus 1, and we have minus b plus 1. So now I can see that b, the common factor, which is a binomial, is b plus 1. So this implies q will be equal to p by, now finding the q equals to p by b is not a necessary step. I am doing this just for the sake of explanation. You should be from here you should be directly able to factorize it as b plus 1 multiplied by ab minus 1. Just for the sake of discussion, I am doing the calculation of q. So p by b is ab b plus 1 minus of b plus 1 divided by b, which is b plus 1. This is equal to ab minus 1. Hence the factorization of p will be equal to b multiplied by q, which is equal to b plus 1 multiplied by ab minus 1. Now I hope you will do the rest of the problems because they are all similar. You have to apply the method of grouping. You have to observe the terms and form groups using suitable terms so that each group will have a common factor. So this brings to an end of this video, where we discussed about what is the basic concept of factorization of a polynomial and how do we factor out a monomial and a binomial from all the terms of a polynomial, and not terms, but if we can see that the given polynomial is having a common factor, which is a binomial, we can factor that out. And finally, we saw how we factorize a polynomial using the method of grouping. That is, if we see that there is no common factor in all the terms of the polynomial, or there is no common binomial as a factor, we try to form groups from the terms of the polynomial so that each group will have a common factor. Also, I solved some selected problems from exercise 7a to support the concept that we discussed in this video. I hope this video was beneficial. If it is so, then please like it, share it with your friends, and also support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will discuss about some special form of polynomial and how do we factorize those special form. I hope those special form are quadratic polynomials, that is a polynomial of a degree 2. So if we have polynomials like let's say p plus, not p, let's say we have, how do we factorize polynomial of a single variable, let's say x square plus px plus q. So this is a polynomial of single variable x, and the degree of the polynomial is 2. So a polynomial of degree 2 is known as a quadratic polynomial. So how do we factorize this kind of polynomial? Also, how do we factorize polynomial of the form say px square plus qx plus r? Also you must be very familiar with the algebraic identities, which will also be very helpful in doing the factorization. For example, these identities a square minus b square, you can immediately, you know that a square minus b square is equal to a minus b into a plus b. So using this identity, you have already factorized the polynomial a square minus b square. Similarly, you will have a cube minus b cube is equal to a minus b multiplied by a square plus ab plus b square. So you have factorized a cube minus b cube as a minus b, product of a minus b, and a square plus ab plus b square. What else you have? Now the basic thing you already know, that a plus b whole square is equal to a plus b multiplied by a plus b. Also a minus b whole square is equal to a minus b multiplied by a minus b. What else do we have? There is another one. You can factorize a cube plus b cube. It is equal to a plus b multiplied by a square minus ab plus b square. So these algebraic identities will be very useful in doing the factorization of polynomials. So with this, I will end this video. I hope this video was pretty long. Sorry for that. I had to solve quite a few problems to illustrate the concept. So thanks for watching, and until the next video, take care and bye.